Hello everyone. So today I'm going to derive an equation for Reynolds stresses, a transport equation for Reynolds stresses. So if you remember from last time, we faced this closure problem for these Reynolds stresses. So we couldn't actually close this equation. So we define a first order local closure kind of to approximate these Reynolds stresses based on the mean variables here. Okay. So now I want to see whether we can go to a higher order closure like second order, and whether we can find an equation for this. So we can add to our number of equations here. So whether we can, by adding the equations for these Reynolds stresses, we can find a transport equation for these Reynolds stresses, whether we can resolve these and find these unknowns and kind of close our turbulence problem. Okay, so we wanna test that hypothesis, and we want to go and find an equation for Reynolds stresses. So in order to do that, first I want to write the Navier-Stokes equation that we had. So the Navier-Stokes equation is du over dt equals to the right hand side, and this is an equation for instantaneous velocity field. So this instantaneous velocity field consists of, we can do a Reynolds decomposition here. So it consists of a mean field, capital U, plus the fluctuations, U prime I dt, equals to the right hand side. So I write this as an equation 1. And then if we take the average of this equation, which we did here, we took the average, right? We took the average here, we got this Rand's equation, right? When we take the average, we get this Rand's equation. So it's going to be an equation for Reynolds average, Navier-Stokes equation, the capital U dt equals to the right hand side, and this is just the Rand's equation. Okay, so now the first thing I want to do to find an equation for these Reynolds stresses is to find an equation for fluctuations. So in order to do that, I subtract 2 from 1, so 1 minus 2 is going to give me an equation for fluctuations, right? So basically what I'm going to do is I'm going to subtract this Rand's equation from the original equation of Reynolds Navier-Stokes equation to get an equation for these fluctuations, like for this fluctuation, right? Before doing any averaging. So I'm not going to do averaging here, just remember, I'm just going to subtract this from the original equation here we had. So we are going to get an equation for fluctuation. So let me just write those terms, and you can confirm them yourself. So it's going to be rho partial U prime I partial t plus capital Uj partial U prime I partial xj. This is the left hand side equals to the right hand side, which is minus partial p prime over partial xi plus partial tau ij prime over partial xj minus rho u prime j partial ui over partial xj minus rho u prime j partial u prime I over partial xj minus u prime j partial u prime I partial xj bar. The last term comes from the Rand's equation. The last term is just this one. I took this to the right hand side. Okay. Okay, so this is now, as you see, an equation for the fluctuations, right? So in order to find the Reynolds averages like U prime I, U prime J, this kind of fluctuations, I'm going to multiply this equation by U prime K. I define a new index. So let's do that. So we are going to get rho. First term is going to be U prime K partial U prime I over partial T plus Uj U prime K partial U prime I partial Xj equals to minus, the first term is for the pressure, U prime K partial P prime partial Xi. Second term is going to be U prime K partial tau Ij prime over partial Xj. And then the third term is going to be minus rho U prime K U prime J partial capital Ui over partial Xj minus rho U prime K U prime J partial U prime I partial Xj plus rho U prime K partial U prime J partial U prime I over partial Xj bar. So we have bar here. Okay. So now what I'm going to do, I'm going to take the error. So this was, I multiplied it by U prime K, the above equation. Now I'm going to take the average of this equation. So let me write it down. Then take the average. So if we take the average here, what we are going to get. So the first term is just an average and it's going to stay because it's multiplication of two fluctuations. The second term, Uj is already an average, so it's just a number, so we can take it out of the average. So it's going to be the average. We just need to do the averaging for these two terms. This term is going to stay. It's again this the average of two fluctuations. We don't know is it 0 or not. Same thing for here. And for this term, again, this is a number, so we can take it out of the average. It's already average, so the averaging only stays for these two terms. This term, the averaging should be for all of them because these are three terms that are all fluctuations. For this term, that's interesting because if we take the average, this is already an averaged quantity, so it will go out of the average. So we can take it out of the average, and then the only term that we are going to take in average is going to be this term, right? Again, because this is an average, so we can take it out of the average. The average of the average is average. So interestingly, we know that the average of this term is going to be 0, right? Because the average of the fluctuations is 0. Okay, so we'll get rid of this term, the last term. So let me write this as equation 3. So now I want to use a trick here. since both I and j are free indices, we can interchange them to yield a second equation. Again, these I and j are just some names, right? So I can just change them, right? They are free indices. I can just interchange them. So instead of I, write j, and instead of j, write I. So what we are going to get is this. If we do that, we are going to get rho let me see, what do we have here? Okay. So I think I'm going to do that for I and k. Just let me make sure that's the case. Yeah, so since I and k, so I'm going to do this with k, not j, to get a second equation. So if we do that, we are going to get this equation. So it's going to be u prime I. Instead of k, I write, instead of k is here, I write I. Instead of I, in this is I write k. So partial u prime k over partial t bar plus uj u prime I partial u prime k or partial xj. This is the left hand side. The right hand side is going to be minus u prime I partial p prime over partial xk plus u prime I partial tau kj prime over partial xj minus rho u prime I u prime j bar partial uk partial xj xj, and then finally we have minus rho u prime I u prime j partial u prime I partial xj bar and let me see. Yeah, I think this should be the number of, let me see, 1, 2, 3, 4, 2, 3, 4. Yeah, this should be the number of the terms that we have, okay? So this is, I named this equation 4. And now, interestingly, let's add equation 3 and 4 together to see what we are going to get. So if we add equation 3 and 4, we are going to get this. So we are going to get u prime I, u prime partial. Let me first write the first term, partial u prime k over partial t plus u prime k partial u prime I over partial t, okay, bar. And what is this? If we do that, based on your calculus, the differentiation, the derivative of multiplication is this equals to partial u prime I u prime k over partial t bar. Right, and then we can take the partial over partial t out of the average, right? So this will equal to this, and similarly, we are going to do the same thing for all the other terms. So what we are going to get is this. We are going to get partial u prime I u prime k bar over partial t plus uj, capital Uj, partial u prime I u prime k bar over partial xj equals to minus 1 row of, and I also divide everything by row, u prime I partial p prime over partial xk plus, this is bar, u prime k partial p prime over partial xi minus u prime I u prime j partial u prime k over partial xj bar plus u prime k u prime j partial u prime I over partial xj, again bar, plus 1 over row u prime I partial tau kj prime over partial xj bar plus u prime k partial tau ij prime or partial xj bar minus u prime I u prime j I'm writing this term now, bar partial uk over partial xj plus u prime k u prime j bar partial ui over partial xj. Okay? So this is very interesting because as you see, now we found an equation for u prime I, u prime k, which is kind of similar to this, the fluctuations. So we have actually found an equation for the transport, and this is, you know that this is the transport of these Reynolds stresses. So we can actually solve this equation in order to find all these unknowns that we had. So we have to solve all these equations, okay? So on the right hand side, okay? So this is actually called the Reynolds stress equation. So now in the next session, what I'm gonna do, I'm gonna simplify and further clarify what do all these terms mean. So I'm gonna name these. The first term on the right hand side is 1, which is related to pressure. Second term, third term, which is related to dissipation, as you see, from tau kj or tau, which is the viscosity. And then we have the fourth term, which we will learn it is actually production term. Okay, so in the next session, I'm going to further clarify these and find another form of these so that we better understand what do each of these terms do in the Reynolds stress equation, and then we are going to write another form of Reynolds stress equation.